Okay, so today I want to go over the different phases of matter. So there's actually 5 phases of matter. You guys are probably familiar with some of these. And the first one is, oh, actually, there's some sounds there. But the first one is Bose-Einstein condensate. And that is something that's a state of matter that's present very close to absolute zero. And one thing that you guys might have heard of is the Heisenberg uncertainty principle that says you can't know how fast something is moving and where it is at the same time and know them both exactly. So when you get close to absolute zero, you know how fast something is moving because at absolute zero, pretty much everything has stopped moving. So since you know how fast it's moving, you can't know exactly where it is at the same time. So when they've taken pictures of matter very close to absolute zero, what they see is that the atoms themselves look a little bit blurry. So we know how fast the atoms are moving, but we can't know exactly where those atoms are, and that's why they look blurry. So it's kind of weird. The next three you're very familiar with: solid, liquid, and gas. And the last one is plasma. This will be at very high temperatures where you separate actually the charges in the atom, like the electrons will be separate from the positive nuclei. So everything has a charge then. Okay, so let's look over the characteristics of each of them. So solids, these have a definite shape and volume. So the particles are going to be very close together and very ordered. And the particles are fixed, but they do vibrate. So here's a little picture of those particles vibrating. But you see that the particles do not take the shape of the container because the shape of the solid is fixed. Okay, the next one are liquids. So the particles are close together, but they move around. So they have no definite shape, but they do have a set volume. So we see here in this picture that they do take the shape of the container, but they won't fill the container unless you had more liquid to pour into that container. Okay, so this would be like you guys in the hallway at school. The next one are gases. So these have no definite shape or volume. So the energy is too high here for the particles to attract each other. And the particles are far apart and they move rapidly. So this is a situation where the gas will actually fill the volume of the container. So that's why it says it has no definite shape and it has no definite volume. So this would be like you guys at the end of the year when you're finally out of school. You're just so happy to be out that you're just running all over the place. Okay, and then we talk about a plasma. The particles are ionized and they glow. And this is actually the most common state of matter because 99% of the universe is plasma. So just some examples of plasma on Earth or in some fluorescent bulbs, in the sun, in lightning, and so on. Okay, so this is just a summary. So you guys can pause the screencast and just write this down. But just know that the kinetic energy is very low for solids, very high for plasmas, density is very high for solids, very low for plasmas, and so on. Okay, so now let's go over physical changes. So when we talk about physical changes to a substance or to a mixture, this is just changing the form of what we have, but not what it's made up of, not its chemical composition. So when we have a physical change, no chemical bonds are broken, no chemical bonds are formed, And so that what we have there is not changed. So when we bend something, when we grind it, we crumple it. All these different words describe physical changes. So any kind of change in state of matter, going from a solid to a liquid, from a liquid to a gas, and so on, would be a physical change because we're not changing what we have. Okay, so some physical changes are irreversible. If you grind something up, you can't really put it back together. The particles are too small. But it's still a physical change because you still have the same substance. It just looks very different. But if you ground up a piece of glass, it would still be glass. It would just have taken a different form. The next one, chemical changes. You're actually forming new substance. So whenever you have a chemical change, you have some kind of chemical reaction that's occurring. Okay, and then the hints that a chemical change have occurred are if you're producing heat or light. This can be an indication of chemical changes occurring. If you see gas bubbles being produced, that's another hint that a chemical change is occurring. If you see a precipitate, so that would be like if you're mixing two liquids together and suddenly you see a solid in the container, that's a precipitate. And you might see a color change. So in this picture here, we also see a color change. So these are all hints that a chemical change is occurring. And finally, you might detect a change in odor. So sometimes in a chemical reaction, a new substance is formed that smells differently. And that would be an indication sometimes that a chemical change did occur. So an example of this too is like if you think about if you have milk in your fridge and it goes bad, the milk will smell differently. So that's telling you that some kind of chemical change occurred. Okay, guys, so what I want you to do now is I want you to try all these and think about if these are chemical or physical changes. Always think about, do you have the same substance or did you turn it into something else? And then we'll go over these. Okay, so let's go over these answers here. So when you're melting ice, this is actually a change in state. You're just going from a solid to liquid. So this is going to be physical. When you're burning wood, anytime you're burning something, this is a chemical reaction. So this is chemical. Breaking glass, you're just changing the form of the glass. That's physical. Painting wood, you're just putting paint on top of the wood. Again, that's physical. It's not going through a chemical reaction. Burning propane, so we have that key word there, chemical. Mixing, anytime you're just mixing something, that's going to be physical. Waxing, you're just adding a layer onto your wood floor. That's physical. Anytime you're cooking, that's going to be chemical. Okay, so now we're going to go through some properties of matter, comparing chemical and physical properties. So physical properties would be something that we can observe without changing what we have. So if you can measure or detect a physical property and without the possibility of it changing into something different, that's a physical property. Chemical properties we're only going to be able to observe during a chemical reaction. So chemical property would be something like flammability. We can only test flammability by actually trying to catch it on fire. So we'd have to perform or try to perform a chemical reaction to test that. That means it's a chemical property. So examples of physical properties. These are all things that we can test without making it go through some kind of chemical reaction. So we could look at the color, the smell. When you smell something, some particles of what you're trying to smell actually go through the air and go into your nose. That's how you smell something. Anytime you're talking about any kind of temperature where things change from one state of matter to another is a physical property. Magnetism is physical. Opacity, how it lets light through, is a physical property. Um, if something's very thick, like ketchup is very thick, it's very difficult to pour out of a bottle. That is that's describing viscosity. Density is describing the ratio of the mass to volume. These are all physical properties. So guys, what I want you to do is I want you to try some of these. So think about, can you test these without making it go through a chemical reaction? So if you could test them and not go through a chemical reaction, it's physical. If you have to do some kind of chemical reaction to test it, it's going to be chemical. So try those out and then we'll go over these. Okay, so now I just want to go over these answers so you guys can check. But when you look to see what color something is, you don't have to change what you have. So it's physical. Density, same thing. Flammability, you're definitely going to might have to change what you have. Solubility, that just means does it dissolve? That would be physical. Reacts, so whenever you see the word reacts, that's going to be chemical. Supports combustion, that means does it help something catch on fire? Definitely chemical. Sour taste, physical. Melting point, physical. Reacts, once again, chemical. Okay, so those are chemical and physical properties, and now we're going to go over intensive and extensive properties. So extensive properties depend on how much you have of something. So examples of this are going to be things like mass, length, volume. Pretty much anything else is going to be intensive. It will not depend on how much you have present. So something like density, density is a ratio. It won't change no matter how much material you have. Any kind of thing with change in state is intensive. It won't matter how much substance you have. Water will melt at the same temperature, or ice will melt at the same temperature. Boiling point, water will boil at the same temperature no matter what you have, how much you have. So why don't you guys try these out? So try these, and then we'll go over these answers. Okay, so let's go over these answers. So anything like mass, length, and volume is going to be extensive. So what I like to do is check off the extensive. So extensive, 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 excuse me. And then everything else is intensive. Okay, so now we just have a few more things to go over. The laws of chemistry. So when we're ever going through any of these changes, there's a couple different laws that we have to follow in chemistry. The first one is the law of conservation of mass. So any kind of chemical or physical change, we have to follow this law. It just says that mass is neither created or destroyed during a chemical reaction. And this just means whatever the mass of what we start with has to equal the mass of what we end up with. The other law that we have to follow is law of conservation of energy. So once again, just like we can't create or destroy matter, we also cannot create or destroy energy. So energy is going to stay the same from the reactants to the products. It can change from one form to another, but the total amount of energy will be the same.